I'm Arnav Kedia from GEM's World Academy Dubai.
Hi, I'm Kamrin Archary from Dubai International Academy.
Today, we would like to present our flying car design for the Senior Aircraft Challenge. We would like to begin by providing you with a short overview of our design intention. We were challenged to design the future of aircraft technology, but we did not want to stop there. We wanted to create something innovative that could truly transform the global paradigm of transportation and revolutionize our perceptions of the capabilities of modern engineering. Thus, we decided to design a flying car. Our intention was to ensure that flying cars were not something that purely existed in science fiction. We wanted to create an aesthetic, ergonomic, and innovative product that insightfully combined features of both aircrafts and automobiles. Based on this initial intention, we were able to create a CAD model using Fusion 360 of our own interpretation of a flying car. We extensively used our creative and critical thinking skills to develop a flying car that could not only serve as an effective medium of transportation, but to ensure that it would also be highly aesthetic to an original car shape so that the potential users would be attracted to the product. Finally, we integrated essential features into the product to ensure that it could be used successfully on land and so it could fly. So, what features does the design have? First of all, we added retractable wings on either side of the plane. This ensures that enough lift is generated to allow the car to achieve flight, which is essential to make the car achieve its functionality from a scientific standpoint. To make sure that this feature is ergonomic, we have designed it so that it folds away into the car when driving. Pursuing this further, on each wing, there's an aileron to allow for the roll motion of the plane. This was extremely pertinent when considering the aerodynamic qualities of an aircraft. We also added winglets to decrease drag and slats to increase lift, which are crucial facets when designing an aircraft. In addition to this, at the rear of the flying car, there are two turbine engines, which will generate enough thrust necessary for the car to take flight. To ensure that the product is user-friendly, we made sure to incorporate horizontal stabilizers to allow for a smooth and comfortable flight, as well as elevators allowing for the vital pitch movement. Moreover, the car is fitted with 4 shock dampening wheels to allow for a smooth landing, takeoff, and drive. Why was this important to consider? The most innovative feature of this aircraft is the ability to be used both as a car and as a plane. Considering the importance that the wheels play in the driving of a car and the takeoff or landing of a plane, we had to utilize the optimal wheels to ensure that the car could effectively fulfill its functionality. To summarize, the smooth aerodynamic design reduces the drag of the plane due to the numerous technical features implemented, while the car also has an aesthetic and futuristic appeal to make it attractive for consumers. Now my teammate Kamrin will be elaborating on the engineering behind the design.
Thank you, Arnav. Here you can see some of the scientific principles we had to consider when designing the flying car. We had to apply various concepts in physics related to forces and motions to ensure that the aircraft is being designed in a way that would enable it to serve its functionality. For example, we had to extensively consider the implications of friction on the design, since this is the force that could affect the motion of the product in both the car and plane form. In our case, the friction that might be created is surface friction and fluid friction, both of which due to the relative motion between the flying car and fluid. In both cases, as the friction increases, the acceleration decreases based on the law that friction is inversely proportional to acceleration. Thus, we had to utilize computational fluid dynamics simulations to minimize friction as a result of air resistance, to ensure that any specific weak points on the car were successfully identified and mitigated. The first step in our research process was to conduct significant research into the scientific principles that could impact the functionality of the product. For example, since we were designing a vehicle that would be in motion, we had to consider Bernoulli's principle, which states that for a given volume of air, the higher the velocity of the air molecules are traveling, the lower the pressure becomes. This was useful when trying to eliminate air pressure points on the car during simulations. Our next step was to utilize 3D modeling techniques on Fusion 360, such as fillets and chamfers, to ensure that the design was smooth and aerodynamic. Fillets and chamfers referred to making extremely sharp edges into smoother curves and cutting small bits of the object. They ensure the aircraft's motion is not disturbed by the constant air pressure or air resistance, as air can instead travel over the smoothest surface. Our final step was to use ANSYS Student to conduct computational flow dynamic virtual testing by analyzing streamlines, pressure points, and velocity. The use of virtual testing allowed us to successfully visualize the air movements around the aircraft, which enabled us to develop and test new designs to decrease drag and high pressure points. With this information, we were able to design an innovative and aerodynamic plane based on crucial scientific principles. Thank you for your time.